so we got our little model here of our juice and our refrigerator. So t, if you want to say this is f of t, that's fine. It's a function of little t. If all these t's are confusing, and this is like y, our dependent variable, little t is like our x independent variable, right? So we can plug in t to get t. Okay, it says the initial temperature is 70. Well, that's this. That's t sub 0. So in my little equation, I'm going to put 70 there. The refrigerator, where I'm putting this thing to cool down, that's 45. Well, that's C. That's the room temperature, or the temperature of the surrounding medium. So that goes here and here. E to the K, I don't know yet. And then we're going to use this. After 10 minutes, the temperature is 55. Well, 55, that's the temperature. And 10, that's little t. So that's little t. And so now I have one unknown k. And that's what I need for the model. Because I know eventually my model is t equals 45 plus 25 e to the kt. I just need k. Well, that's right here. I can solve for k. So to do that, I want to isolate. This is an exponential equation. I want to isolate this. Well, I'm going to subtract 45 from both sides. This is 25. Divide by both sides by 25. Well, that's something. 2/5 or 0.4. Well, this is exponential. And what's the inverse of an exponential? A log. This is base e, so natural log. Natural log. That cancels. The natural log of 2/5 is just something on my calculator. And so this is 10k equals that. We'll just divide by 10. So I'm just going to type that in my calculator. I'm going to type the natural log of 2/5 over 10. Negative 0.92. But now I'm going to go stow k. Stow k. Because now I have my model, and now that goes right here. Negative 0.92t. So there's the model. Check. Phase 2. What is the temperature after 15 minutes? Well, that's t equals 15. So I can just plug in 15 right here. So now I'm going to just say, okay, 45 plus 25 e to the, don't type in that number, k times 15. So there it is, 51.324 degrees. Now, I'm just going to see if that makes sense. The refrigerator's 45, right? So eventually this has to cool down to 45. At t equals 0, it's 70. So it's cooling down. At 10 minutes, it was 55, right? So does it make sense that at 15 minutes, it's 51? Yeah, I can believe that. That makes sense. Then the last one, when is the temperature 50? Well, then I just need to go to my model, and I'm going to do it down here. I just need to take my model, 45 plus 25 e to the negative 0.092t, figure out when is that 50. Well, this is an exponential equation which I know how to solve. So I'm going to subtract 45 from both sides, divide by 25, so that's 1/5 equals e to the 0.092t. Natural log, that cancels. So divide both sides by 0.092, which is k in my calculator. So if I just do the natural glare, if I just do the natural log, whoopsies, of, whoopsies again, 1/5 over k. So 17.564 minutes. Which again, hopefully makes sense. At 15 minutes, it was 51. So yeah, I can believe at 17 minutes, it's 50. And so that would be all three parts of that problem.